let's do the 2D basics array practice. Like I say here, ideally you should be able to solve these and then go back and solve them again and again and again, throwing away your solutions every time until you can just type them all out without thinking about them. Because a lot of the basics here are things that you really want to just have in the back of your mind without thinking as part of being fluent in the language. So here we go. I guess let's look at the problem. So first is displaying a 2D array. We'll write a method for that takes a 2D int array as input and has no output. So let's go ahead and program by intention. First, I'll create a 2D array called test. This is a good thing also to have in the back of your minds. Just know how to declare an array like this. All right, and so now I'll say print test, and then you can hit Alt-Enter or Option-Enter, maybe it's Command-Enter on a Mac, and it will create the method signature. I'm going to call this array. Okay, so using our IntelliJ shortcuts, I'm going to loop over all the rows, starting at 0, going up to array.length. Then I'll loop over all the columns, starting at 0, going to array row.length. And then I'm going to print. Well, here let's do a bug first. I'm going to print line the value of the array at the particular row column with a space afterwards. And then here outside this for loop, this is like displaying all the values in one row. So when I get to the end of the row, I want to just have a print line that displays nothing. So we can run this, see what it does. And you will notice that it's displaying my array, but each value is on its own line. And the reason why is because I'm using a print line here. Every single value that I visit, I want to print it, but without going to the next line, because I only want to go to the next line when I actually get to the end of the row. So let's run it one more time. All right, great. So that's looking more like it. For part B, it's saying let's type out the same thing, but now let's change it so that it uses the for each version of the for loops. So in the for each for loop, we give it a data type. So we're going to loop over all the elements of grid, and each let's call this grid. So each element of grid is a row, and each row is a one-dimensional int array. So it's like I'm going to assign each one-dimensional row to this variable one at a time. But then I also want to loop over those. So I'm going to have a value, and I'm going to loop over each element of row. And then the rest is just the same. All print line, array. Oh, no, sorry. The rest is not just the same. So here I can't do this because I don't have any indexes. Instead, value is already the thing I want to be displaying. So I'll have val followed by space, and then empty. And then again, let's run it and test it. Make sure it works. Okay, great, works. So again, ideally you should be able to kind of retype those from memory. The for each version is less important. It's okay if you can't type that from memory, but you should definitely be able to type the main one from memory. Okay, so what next? It says, let's make a method to create and initialize an array. So it'll be called create array. I give it the width and the height of the array I want, along with the initial value, and it creates and returns it. Okay, so let's do this. Again, I'm going to program by intention. So I'll say int bracket bracket test2 equals create array. And I'll give it some values like 4 by 5. And then I'm going to initialize it with 3s. I'll let it create the method signature for me. This was the width. This was the height. And this was the init value. And those all came from the problem description. So the first thing I want to do is create a new array. So let's give it a data type. I'm going to call it array, and I'll say new int. And then you have to remember what number goes in here, what number goes in there. So it's always rows, then columns. So you might be tempted to say width height, because that's the order the parameters are given in the method signature. But height actually tells you how many rows, and width tells you how many columns. And it's always rows first, columns second. So now that I've created the array, now I can loop over it. So let's go up to height, and then let's go up to width. And then let's say array at that particular row column gets assigned the initial value. And then at the end, we have to return the array. So again, we can test to make sure it worked. I'm already creating the array, saving it into test2. So now let's go ahead and print test2. There we go. Looks pretty good. And if you want to, you can, try changing different things. Let's initialize them to -1. Okay, looks good. All right, so for part B, it's the exact same thing, except we're going to create a string array. So I'm actually going to copy and paste the method, but I'm going to be returning a string array, and the initial value is going to have to be a string. And other than that, oh, what is happening? Oh, sorry. So this has to be a string array. All right, cool. And so this also has to be string. Because when you're creating an array, you have the data type here and the data type there. So now everything matches. I'm returning a string array. I have a string array variable on the inside. That's what I'm returning. Cool. So let's go ahead and test that. Here I'll have string bracket bracket test3 equals create array 3 by 5, except this time I'm going to initialize it to high. And we'll do, except I don't have a version of print that takes a string array. So let's also copy that. If you don't remember what it's called to have the same method name but with different parameter lists, it's called overloading. So we're going to overload the print method. Okay, cool. So it does the same thing, except we take a string array as input, we loop over the rows of strings, and then the values are all strings. All right, so now we're back up here. It should work. Let's run it and see. Cool, so we got a bunch of highs. That seems to have worked. All right, what's next? So array with a border. Create an array with a filled border. Okay, so create array border. So the beginning of this is going to be just the same as the other one. We need to make the array, except instead of filling the whole array, we're just going to loop over the border. So let's do that. Is this with ints? The answer is yes. So int bracket bracket test4 equals create array with border. It'll be a 3 by 5 array. We're going to initialize it with -1s in the border. Again, I'll hit Alt Enter, Command Enter. Let's rename these. So what's this? This is width. This is height. This is border value. I'm trying to use good names that describe what the variables are. So I'll start with the same way. I'll say array equals new int height width. By the way, you might notice that I'm using tab completion a lot. I'm doing H tab and then W tab to speed up the typing. So now I don't want a nested for loop to loop over all values. I just want to loop over all the outsides. So you could make 4 separate loops like this. I could say, let's loop the row going from 0 up to array.length, and I'm going to assign row R column 0. So this is like looping down the left-hand column. Because remember, the column value here, 0, is never changing, and 0 is the leftmost column. So the row number is changing and going over all the rows, but it's all the rows in the leftmost column. And we could say border value. If I wanted to, now I could do the same for loop here, except instead of the leftmost row, the leftmost column, we'd want the rightmost column. And the rightmost column is array 0.length -1. So that would work. Something I'm noticing, though, is these two for loops cover the same range of rows. So there's no reason why I shouldn't assign both in the same for loop. So now I'm saying visit all the rows, and for each row, assign the border value to the leftmost column and also to the rightmost column of that row. And so then I can do the same thing for columns. Let's loop over all the columns, going up to starting from column 0, going to the last column. And then we'll have the same thing, only the row is going to be 0, and we're going to visit all the columns. So this is looping across the top row. And then we also want to loop across the bottom column. So the bottom column is index array.length -1. Oops. And then C, we want the column values to change. Something to note here is that we've actually visited all 4 corners twice, because we visit the corners in this loop and we visit the corners again in this loop, but that's not actually hurting anything because all we're doing is assigning the same value. And then at the end, we'll return array. Let's go ahead and run the test. Oops, so let's change what I'm actually printing out. Great, so it looks like -1s around the borders. Okay, what's next? Next we've got find the minimum value in an array. Great. So print find min value of, let's do it with our first test array there. I'll hit Alt-Enter, Command-Enter to automatically generate the method. Oops, except I don't want to call this test. I want to call it array. So I think what we want to do is the find the minimum pattern, which means we're going to loop over all the places we might want to check, and we're going to compare them to a variable that's the minimum so far. So one thing you might do is initialize the min so far variable to array 0, 0. The only danger here is, what if you're passed an array that has size 0, so you don't even have one element? So you could, to be safe, you could do something like this. If array is null, or array.length equals 0, or array 0.length equals 0. So like if either there is no array or if either of the dimensions are 0, then we could return, oh, this should be returning just an int for minimum value. Then we could return something neutral. -1 isn't really neutral. I don't know what we would return. I hadn't thought that far out. Anyway, this is probably less important. That's like an edge case. You could initialize your minimum so far to be the upper left-hand corner. Then you can loop over all the rows and columns. You'll notice that it's the same pattern happening here a lot, where we loop over all the values. And we'd say if the value at the particular row and column is smaller than min so far, then what I want to do is save a new value for min so far. I want to take the value I just saw that was smaller. It is the new minimum. And so by the time we're done, we've visited all the places. And so min so far should be the smallest number. So we'll return min so far. So that's one way to do it. A different way to do it is, if we're trying to find something that's the minimum, we could initialize this to be the largest possible integer, integer.max value. And the reason why max value is because we're sure that the very first thing that we look at is going to be smaller than the max value. And so min so far is going to get replaced with an actual value from the array right away. So either of those approaches would be fine. Let's go ahead and try it out. So here, instead of print, let's do print line. What do I call it? Find min value of test. Let's run it. You'll also notice that I'm testing each program as I go. So 1, cool. Let's make this like -3 and run it again. Now the minimum value should be -3, and it is. Okay. So part B says get min val column. So I'm supposed to return the column where the minimum value occurs. Let's do that. So find min value column. So let's do this. I'm going to keep it all the same. On some people's like midterms, or I don't know, some test you took, people did this. Like they found the minimum value, and then they had a second set of for loops where they went through and they said, if the array is equal to the minimum value, then return the column where we saw it. That's going to work. I'm looping over all the things, replacing the minimum as I find smaller and smaller values. And then I'm going to loop over it all a second time so that I can find the actual minimum's location again and then return its location. It's a little bit unnecessary to do that, though, because what I could do is I could save the min column. Let's set it to -1 to start with. As soon as I find As soon as I find a new minimum value, I know where it is because I just looked at it. So I can save the min column right away because I know that the value at RC was my new minimum. So let's set the new minimum, and let's also save C as the column where it happened. And so now by the time we're done, we can just return min column, and we can be guaranteed that it's actually the right location because we set it right at the moment that we found a new minimum value. Okay, let's run that one. Find min value column. Let's run it. So here I think it should be 1, yeah, because -3 is the minimum value. This is column 0, this is column 1. All right. I think we're getting close to the end here. Get min interior value, so return the minimum value that's not on a border. So let's go back to find min value. Let's copy paste. I'll call it find min interior value. So one thing you could do is before checking this, you could check to make sure that row and column aren't on a border. This is not the best way to do it, but you could do this. You could say if R is not 0 and R is not equal to array.length minus 1, which is the last row, and the column isn't 0 and the column isn't equal to array 0.length minus 1. So that's basically like saying, if it's not on a border, then check to see if it's the new minimum. But that's, first of all, like a little bit ugly. And second of all, we're still looping over all of the border elements. It's just that when we hit a border element, we say, oh, you're on the border? Okay, let's skip you for the next time. It would be better if we didn't actually loop over any of the border elements at all. So instead of starting at row 0, let's start at row 1. Instead of starting at column 0, we'll start at column 1. Instead of ending at array.length minus 1, we'll make sure that the row is smaller than array.length minus 1. Since this is the last row, we're saying our R variable has to be smaller than the last row, which means that we're never visiting the last row. Here, we're never visiting the last column. So other than that, it's just the same. Okay, I'm not going to test that one. Let's just move it right along here. So diagonal sum, cool. So we've got to kind of loop along the diagonal. What does it say? This one, why did I include this one in the basics? Okay, so this one is sort of like the stretch problem for the basics. I would say this is not basic, but it's good to know about. So if the array is square, it returns this thing. If the array is not square, it returns 0. So I'd say if the array is not, all right, well, so hold on. Let's set this up first. This is called diagonal sum. Let's create it. Array. Except it's supposed to return an int, not a Boolean. Okay, so if the input array is square, then we have to loop over the diagonals. If it's not square, what did it say? We just return 0. So let's just test to see if it's not square. It's not square if the length and the width are different. So if array.length doesn't equal array 0.length, so that means length and width not the same. So if that's true, then we return 0 because not a square array. Okay. If we don't return, that means that it must be a square array. So now let's figure out how to loop along the diagonal. Some people might be tempted to have that same nested for loop pattern where we're looping over rows and columns because you're thinking, oh, if you're looping along the diagonal, it's like rows and columns are both changing. But the thing to realize is you only use a nested looping pattern if you're changing all of the columns for each row or all of the rows for each column, if the two variables are changing independently. If you want to loop over the diagonal, you might notice that the row and column are always the same as each other. So what would be better is this. Let's loop over all the rows, array.length, but then a diagonal element could be array row, row, row. Because along the diagonal, or along that particular diagonal, if we use row as our column value also, that guarantees that we're on the diagonal. Let's create a sum variable that we set to 0, and we can say sum plus equals that. Cool, so that's now the major diagonal starting from 0, 0 going that way. What about this other diagonal? It's like we'd want, when the row is 0, we want the column to be what? Let's count. 0, 1, 2, 3, 4. So the column starts out as the last column, and then each time the row goes up, the column goes down. Row goes up, column goes down. So one way you could do that would be like this. You could say int c equals, let's set it to be the last column. And now we'll say, let's add array row column. And let's think about what this is going to do. The first time through the loop, r is 0, and column is the last column. So that's going to give us that upper right-hand corner. And then each time we go through the loop, row is going to increase by 1. So let's subtract 1 from the column. So that way, every time we loop, the column numbers are going down. So we're sort of looping in a coordinated fashion. That would work. That would be just fine. Another thing to notice is the value that we're subtracting is the same as whatever r is. So let's go back to the picture. So here, when r is 0, we subtract 0 to get the last column. When r is 1, we subtract 1. When r is 2, we want the last column minus 2. When r is 3, we want the last column minus 3. So you can use that pattern, and you don't need this extra variable, and you could say the column is always equal to the last column minus whatever our row number is. And so that's like a very condensed way of doing the addition. And then we can return the sum. So the only thing that we have to think about now is, let's see, in this picture, here we have an odd length square array. And if I add up 3, 2, 5, 2, 0, and then I add up 1, 1, 5, 9, 1, I've counted this middle element 5 twice, but I don't want to count it twice. But notice that that's only going to happen when your array has an odd length. So before I actually return it, I think what I'll do is I'll test for that. I'll say if array.length mod 2 equals 1, so that's if it's odd, then I'll say sum minus equals, and then I need to subtract the middle element, which will be array.length divided by 2 and array.length divided by 2. Okay, so now I'm not double counting. And this is sort of like a weird enough line, I think it merits a comment. So subtract double counted middle value if array length is odd. So that'll just remind me what this line is about if I ever have to come back to this code. Okay, so if we really wanted to, it would probably be worthwhile to type in this array and then run it to make sure it works. Like I said, though, remember that, so this last one was kind of a tricky one, definitely not a basic one, but you should definitely be able to go through and type all of these other ones relatively rapidly. It's been 23 minutes, but I've been explaining as I'm going, so I think you should be able to type all of these out with the exception of the last one in about 15 to 20 minutes probably. Okay, I hope this was helpful. Good luck.